Hello, everyone, and welcome to our virtual edition of our presentation here on Jamf Pro APIs and their modernization. I'm Pat Norton, a senior platform engineer at IBM. I'm joined here by Jan Velatnik, a software developer on my team, as well as Nor Jabaya, who's also a platform engineer on the Mac at IBM team. Let's get right into it. Jamf provides administrators with two different API endpoints to choose from, the Jamf Classic API and the Jamf Pro API. Not all of the JPS information is available from both APIs, to my knowledge, but don't quote me on that. I primarily use the Classic API because it's the API interface that's been around the longest. The Classic API, as of version 10.35, supports both basic authentication and token-based authentication. API, if you're not familiar, you're probably in the wrong session, but maybe you could learn something, hang around, stands for Application Programming Interface. And APIs are the key to most automation efforts because they allow us to pass information to and from the JPS with automated scripts and other workflows that don't require us to interact with the graphical user interface or the website. With the impending change from Classic to token-based authentication on the Classic API, we must begin switching all of our scripts to use tokens so that IBM can continue modernizing our program and upgrading the JPS when new versions are released. We do use quite a few API calls, and most of the ones that I deal with on a regular basis are Classic API endpoints. The most commonly used are getting information about a computer to update the endpoint, the computer itself, posting information to text extension attributes, locking machines, and a few other tasks I'm probably overlooking at this point. Some of the scripts that we use run at a very rapid cadence, as often as 1 minute in some of our test environments. With scripts running that frequent, we don't want to be requesting a new token for each script every minute. This requires that we store the token in some format or another. Some of you may have seen the presentation from JNUC last year where we showed some of the ways that Mac at IBM uses webhooks and the API to generate metrics and monitoring that are critical to the success of our program. This is just a quick recap of those components that are related to webhooks and API interactions. First, we have our PHP webhook receivers. These are PHP files that receive a webhook event and either write that event to a file or a log that's then ingested into one of our databases. Zabbix is an open source infrastructure monitoring tool with an agent on each of our servers. We use heavily the custom script capabilities of it to process webhooks and create a time series of useful data that we can then display. We also use Elastic Cloud Enterprise. Elasticsearch is an enterprise NoSQL database that we use for storing and aggregating log messages as well as custom data. We use it for the Jamf Pro logs, server logs, as well as collecting an entry for policies and other executions, as well as custom data scripts, metrics that we're going to then display on dashboards. When we come around to the API, Python processing scripts do most of our heavy lifting. We use several different scripts to process webhooks and make API calls back to the JPS. These scripts collect and process a subset of computer information, including custom extension attributes that we then store in our MySQL database. This allows us to have a single table of information, similar to computers denormalized, that other teams at IBM may access for reporting, security, and other internal processes without needing to execute complex queries against the Jamf Pro database directly. These are the scripts that are going to have to be updated when we move to token-based authentication. And finally, Grafana is another open source display tool. It's our presentation layer, if you would. It supports many different data sources: MySQL, Zabbix, Prometheus, Elasticsearch, Influx, many data sources. This allows us to build very complex dashboards that draw in data from multiple sources and display them all together. Now, Jan is going to take us through some common API authentication methods. Jan?
Okay, thank you, Pat. So yeah, before we dive into the new method that Jamf is going to introduce, I would like to mention different methods that are currently in use to authenticate to APIs. So basically, the most used, it's HTTP basic authentication. That's the one that Jamf Classic APIs used up until now, and it consists of sending username and password, base64 encoded, in each request. And the biggest disadvantage of this method is that server needs to check each time you make a request. It needs to check if you have a valid account, and so it's heavy on resources. And the other one is that this method doesn't scale well in current cloud environments, where each microservice would need to basically do its own verifying of your authentication. Next one is API keys. This one is a lot easier for server to use because you just have one token, doesn't have to do databases lookup. And however, the disadvantage of this is that once you get the API key, basically you will have access to all APIs. There is no permission system on this one. And that's why there is a OAuth or OAuth 2 with OpenID, which actually solve all these problems. It's very lightweight in terms of that server doesn't need to do lookup for account on each request because a token carries this information with itself. Tokens are self-expiring, and it's very well scaling in cloud environments. Next, Nor will tell us more about transitioning from basic to token-based authentication.
Thank you, Johnny, for that overview. For those who may not have heard of bearer tokens, you may be familiar with the concept of bearer bonds, where the holder of the bond is the owner of the asset. The concept here is much the same. Simply, the token can be described as a machine-generated cryptic string. It is an access token used by the OAuth authorization framework that Johnny just mentioned in the previous slide. In order to generate the token, we use basic authentication to send a post to the auth token endpoint. This will then generate this JSON object that you see here on the screen, which contains both the token itself and the token expiry, as seen on the screen. Right? Some features to highlight are that the token is stateless. Unlike your username and password that are stored in a database somewhere, the token is self-contained with all the information needed for authenticating the request being made. Additionally, these tokens are lightweight, as Johnny mentioned. They are not very resource intensive on either the client or the server. Pat had already alluded to this, but the Jamf implementation of the bearer token includes a set 30-minute expiry, meaning the token already becomes invalid after 30 minutes. For a lot of us, 30 minutes is plenty of time to run our calls, and so this introduces the need to invalidate the token when it is no longer needed. And we can do that using the invalidate token endpoint. Pat will actually show us an example of this later on in our deck. A few more things to keep in mind. Token-based authentication has always been available to the Jamf Pro API. It was just introduced to the Classic API in version 1035. In Jamf Pro version 1036, they also introduced a feature allowing us to disable basic authentication to the Classic API. Additionally, with that information, that basic authentication is expected to be fully deprecated later in 2022. Our best guess now is August, towards the end of the year. This is all just forewarning to all of us to prepare our environments for these changes. Update your scripts and workflows as necessary. Next, Johnny will cover how to use these bearer tokens in a few example calls.
Thanks, Nor. Yeah, so here we have an example of a real call to Jamf Pro server. In this case, it uses Classic APIs, and it's actually API endpoint to request authorization token. As you can see, it's exactly same like before. You pass first username and password, which is base64 encoded and attached to header of the request. And when this call is issued and the credentials are valid, server will return bearer token. We can see it in next slide what it looks like. So if we want to now call another API on the server, we need to actually attach this new token to header of the HTTP request. We can see that it's changed since the previous one. We have now authorization and bearer token and this huge long string, which looks like some cryptic, but it's actually plain text with a very well-defined structure. There is a header, then payload, and then signature. Each part is divided by dot. The next slide, we have actually example how we can all this combine into one script. So this is basically a real case scenario where we want to issue remote MDM command to lock Apple Silicon device. So first, as I mentioned, we request the token from server. We authorize with our username and password. That's on the get API token method. Server returns the token along with information about its validity, which we pass out. And next we call the real API attached with this token. If all went well, the device will get locked. So this is a short example how this all can be combined into one script. And next part will show us some,
That's okay, Johnny. I'm ready. I'm ready to go. Okay, so I'm going to dig into some example scripts here that I wrote for this presentation as we started looking at this process at IBM. There are two methods that I thought that would be useful for managing tokens. Since most of the scripts that we run here, as I mentioned before, are on intervals of less than 30 minutes, it makes sense for us to store that token rather than to continue to request new tokens. For those of us with shell access to the servers, a text file seemed to be the simplest method to store a token. So I'll show that along with storing the token in a database as an example for maybe somebody who only has application level access, Jamf Cloud or another environment like that where you don't have the ability to write files directly. So standard disclaimer should be mentioned at this point. These are example scripts that were written specifically for this presentation. They should not be used in production without any extensive testing. They worked as examples to highlight some options that we chose to implement, but they've not been thoroughly tested. And if you want to use these in production, please do some testing first. First, I'm going to cover the example that I mentioned, the text file. This script is just going to make a token request to the JPS and then write the token and expiration to a file so it can be retrieved later by the script that's running and needs this token to make its authentication request. By the way, all my things are in Python. My scripts are in Python. That's my preferred language of choice, but the logic is the same, any language that you would choose to use. Also, all these scripts will be available to download in the resources section of the presentation, so don't worry about the formatting or trying to read them. Here we have some debug from the previous script. We see that at the top there's a 200 HTTP response, which indicates a success, as well as the full response in JSON from the token API. In addition to printing the JSON keys for token and expiration. Of course, that's kind of redundant here, but it was nice to show the method of how you can access those key pairs from the token response, or from the response from the token API. Okay, here is another Python script that is going to store this in a MySQL database. Much of the code in this script is the same as storing it in a text file, except we have a slightly different function. which is going to interact with the database and inject that token there rather than store it in a file. So this script and database structure manage the token by an ID. That was my way to make them unique. So each process running would need to be assigned a token ID. So that script will update and manage its token rather than getting the wrong one. Here we see another set of debug outputs from the previous script, the MySQL one. 200 HTTP response, and then the token request along with the JSON token output. Also shown here is a MySQL select statement that is indicating that the token was stored along with the expiration as token ID number 1. In both of these examples, there needs to be something managing the token lifecycle. How do we execute a script every 30 minutes to make sure that that token does stay valid? Option 1 here, perhaps a cron tab entry on the server could be run in an interval of 20 or 25 minutes. That cron would make sure that one of the token request scripts shown always has a fresh token, either in the text file or the database, ready for the other scripts to read and use. The other option, which I'll show in some of the next slides, is to maybe have a function that checks the expiration of the token that we've stored, and if it's expired, then execute a different function to refresh that token before using the token to perform API tasks. Okay, so now that the token is stored, we can use that token to make an API request to the JPS. Here's an example script that is going to read that token from the text file. And I've added that function that can validate the token in the text file based on the expiration so that the script doesn't make an API call with an expired token. As I mentioned previously, this could be an option to manage the token instead of that cron tab entry or systemctl or whatever you'd like to use. It's really a matter of choice, but the basic flow is the same. We're going to validate the token. If it's not valid, we're going to request a new token. And once a good token is written to the file, then we're going to make an API request to the JPS with that valid token. This slide is going to show a little bit more debug. We see that the token is still valid at the top little debug statement, so that the script will go ahead and make the API request. The JPS responds again with a 200 and then outputs information that was requested in the API call. In this case, it was for a subset of information about a particular computer ID. That computer information is printed out in JSON here. The script could do something useful with that information, store it in a middleware system like I described we do, or perform whatever task is necessary with the information that's returned. The MySQL version of the script is a little bit more complex because of the database interaction, but the workflow is basically the same as the text-based storage option. We're going to read the token from the database, validate it. If it's not valid, then we're going to request a new token. And once a good token is obtained, we're going to read that, read it back from the database or store it in memory, make an API request to the JPS. And here we have some more debug from that previous script. We see that the token is not valid at the top, so it's going to go ahead and request a new one. A new token is stored as ID number 5, and the API request is made. JPS again responds with a 200 and outputs the information requested from the API. In this case, it was again for a subset of information for computer ID. That computer information output in JSON here. And one final example, Nor touched on this briefly earlier, which is how to invalidate a token. Here's a Python example of how to do that. Just seemed prudent to include that. In some scenarios, it may make sense to continue to extend the life of a token, which you can do. There's a bunch of different token manipulation tasks that are listed in the developer Jamf website. You can go on there. Say you were in a really secure environment where the human needed to provide the first basic auth to get your token, and then you could continue to extend the life of that token on an interval, so that way there's no credentials stored anywhere. or a bunch of other options, but a human is involved in generating that first token. So you can continue to use that token, extend its life until you decide to invalidate it, which a script like this would do, or a simple curl statement that was provided earlier. And now Nora is going to take over and talk about how to manage your token.
Really just a simple take-home message here. Two things in summary of what Pat discussed. If you need to store the token, go ahead, but really only if it's necessary. We don't want to be keeping this token valid and available when the workflow doesn't demand it. So really only store your token if you do need to. Take a close look at your workflows and evaluate if that's necessary. And second, invalidate when it's not needed. It is very easy to do so, to generate and to invalidate the token. We just don't want to be keeping it available and valid when it's not needed. So just want to take those 2 points home and reiterate them one more time. Next, Johnny is going to discuss some ways that you can securely manage the credentials used to generate the token. So not the token itself, but how you generate the credentials used to generate the token.
Thanks, Nor. Yeah, so we talked about the tokens itself, how to store them, how to use them, how to invalidate them. But one thing also important is how to basically store credentials that you need to get the token itself. And it really depends on environment your workflows are running. So for example, if you are in server environment somewhere, the preferred solution would be environmental variables accessible only to that specific instance of the server. So basically no other member can reach them. If you are on macOS, there is a keychain which you can use for this. It's very secure and it's very easy to work with. Or another option would be, and that's especially in cloud environment, it's a centralized secret store. And basically, such as IBM Secrets Manager or AWS Secrets Manager, and their advantage is that they have automatic key rotation function. So basically, you don't care about the management of the system. You just request the token when you need it, and the system will take care of its own. And this basically concludes our quick intro about authentication to APIs.
Thank you all for joining us today. Really wanted to highlight the developer.jamf.com documentation. It is excellent. I mean, they have every code snippet that you need in a really easy to use format. I've really found them incredibly thorough and really easy to follow along. So I highly encourage everybody to check those out. I had a screenshot of some of those in an earlier slide. Very, very handy. And just as a final summary point, all the scripts that you see in this deck will be included in the session handouts. I know I already said that before, but make sure to keep an eye out for those and really use those with caution. This is these are scripts that were made for this presentation. This is not production code that you should just put on there. And really, finally, thank you all for being with us today. We've really enjoyed having this informational chat with you all and looking forward to seeing everybody at JNUC 2022. Thank you so much.